Awesome. Great. So yeah, now we're sharing live on LinkedIn and Twitter as well. And we were just sharing that we'll be doing two webinars, one next week on working with Spark Redis to build a feature store, and the one the week after comparing open source feature stores, Feast and Featureform. But today, I'm really excited for this one. We're going to be talking about building an MLOps platform from scratch. Any questions at any time, throw in the Q&A, please. So who am I? My name's Simba. I am the creator of Featureform. Featureform is a virtual feature store, which we'll go through that and go into what that means and what that is. I started my career at Google. I was a software engineer there for a while. In my last role, I was building recommender systems, personalization, predicting subscription, predicting churn at a really massive scale, like hundreds of millions of users. And in that role, um, we built an MLOps platform from scratch. This is before MLOps was a term. We built a feature store before that was a term. And from there, I decided to go full time on Featureform, which is now open source. Um, so today, we're going to talk about MLOps. We'll start with defining the MLOps North Star, like what is MLOps, why do we care? We'll break down the ML lifecycle, which is obviously deeply tied to it. We'll go into building an MLOps platform from scratch, from data, training, deployment, monitoring, and then we'll talk about measuring success. Because obviously once you're deployed, it's an iterative process. It's not like the platform's ever done. And then finally, I'll have a little aside at the end. A lot of people ask about how do MLOps and LLM ops work together? How are they different? And so I do want to make sure I touch on that topic as well. Um, but yeah, most of what we're going to do is talking about the different pieces of the MLOps stack. I will be showing some code as we're building it. I'll really be focusing on the different tools for the different pieces and really showing you how to think about those tools and how to implement them. I want to maybe take a moment just to talk about MLOps as a category, how it's changed over the years. Um, I actually think that now is probably the most exciting time to be working in MLOps because we've kind of passed, there was like almost this crazy bubbly hype stage that happened a few years ago, where there was a ton of tools, there's like a million tools. It wasn't really clear what worked and what didn't work. And it was too noisy and there wasn't a lot of value. And I think that kind of, came to a crash in 2023. And now we're back in a good position where we're really focused on creating value with MLOps. MLOps is kind of stabilizing. There are best practices now that I can share. In 2021, I could only share what I thought was best practices. At this point, there are patterns emerging. And another thing which is really important is the ROI is more critical than ever. So you really have to be able to um, define MLOps, define your platform, and tie it directly to your return on investment. So gone are the days of just like using every shiny new tool just because. When people learn machine learning, like if you take a Coursera course or something, like you learn machine learning as such a simple process. It's really focused on the model. Everything's about the different types of models. Models take features as inputs and they make a prediction. When you train, you compare your prediction to a label and adjust your weights accordingly. Um, but in reality, that never happens, right? Like in reality, we have lots of different people. We have notebooks everywhere. We're doing analyses. We're building data platforms. We have different features everywhere, different training sets everywhere. We have a ton of different experiment runs that generate tons of different models. We have production, which is completely different from experimentation. It's way messier than the perfect Coursera course style machine learning where you have a perfect CSV and you train on. Unfortunately, that doesn't really exist in the real world. Um, and so MLOps was created to solve this. MLOps is a set of tools and practices to automate and streamline the model lifecycle from ideation all the way to production. So obviously, MLOps, operationalizing machine learning, like it helps to understand the ML lifecycle. So these are kind of my breakdown of the four stages of machine learning, of a model. And also as a data scientist, I would say these are like the four different modes I'm in. That's not linear, as it's kind of implies that it's linear. You go from left to right. You can, but oftentimes you're kind of jumping between them or even thinking about multiple of them at the same time. Like for example, when I'm doing model experimentation, I'm usually thinking about data too. If I'm doing monitoring, I'm also probably thinking about data. I'm also maybe thinking about the hyperparameters and different the type of model. So these things are all very deeply tied. But I would say that there's four different mindsets and actually four separate types of tools in an MLOps platform for each of these different steps. So firstly, there's the data set. In the data set, we will be building data sets, we'll be analyzing our data, we'll be building features, building training sets, eventually even serving those features for production. Um, that's the first piece. Um, when you think about this, like as I'm working with I'll typically if I join a company and I'm a data scientist, and I have a specific project maybe I'm assigned to, or maybe I need to think of how to drive value to the company. I'm always going to start with the data. I want to understand what that data is, understand the peculiarities of it, understand the basics of the distributions of it, just really try to get a feel for the data. And when we're thinking about MLOps, one big piece is thinking about how to do the data engineering part of ML better. As I start getting into actually building models and trying models and experimenting, I'm going to be creating a lot of different runs. I'll be creating a lot of different models. I'll be exporting those in certain ways. So I have some form of model store. I want to be able to understand what models are, how I train them, what the model is, just basic hyperparameters of it. Eventually, we have to deploy these models. And that comes with its own set of challenges too, where I have to take the model that I trained and actually get it into a setting where I can serve predictions. Sometimes it's easier. For example, in a batch scoring use case, it's a bit simpler, but it's not exactly easy. And for other use cases, like real-time use cases, like fraud or recommender systems, it's quite um, in depth getting that to work. And then finally, once the model's in production, we need to worry about monitoring and evaluation. Just because the model's in production does not mean that we're done, typically. It typically is just a start. It's one iteration cycle because then we can see how the model's performing. I've yet to ever deploy a model that just worked perfectly and didn't have edge cases, didn't have bugs, didn't eventually degrade a bit. Having monitoring and evaluations understand helps us understand what the model is actually doing in production and why. And that will also typically lead into an iteration where we'll switch back into the data mode. We'll maybe play around with different types of models or different parameters of those models, or even maybe play around with how we're deploying. Maybe it's performing well, but it's too slow. And so we have to go back into the deployment stage and optimize that. I'm going to go into the tools of all of these four stages, but I kind of want to start. So we're talking about MLOps. Um, we're trying to, again, like operation, like get this life cycle. What we're trying to do is make it so as a data scientist, I can move very quickly. I can collaborate well. It's just especially relevant if you're a big company. And there's lots of risk mitigation. I can't accidentally break production. I can't accidentally deploy a model which is completely wrong, or maybe uses data it's not supposed to use due to regulation. So those are the th three pieces: velocity, throughput, which is kind of like collaboration, and then risk management. everything and pretty much everything, especially in the experimentation part of data science, is done via notebooks. And I think this is probably the first place to start. If I was building an MLOps platform from scratch, all my data scientists are using notebooks, almost all. I actually was one of the few who used Python files because I came from a software engineering background, but even nowadays, I mostly use notebooks. Um, so the first question is figuring out one, what do your data scientists use? And the answer is almost always going to be some form of Jupyter Notebook. Now, you can use notebooks locally, and a lot of people do, obviously, and that could be a good way to go. If you use tools like SageMaker or Vertex or any of the platforms, they kind of push for notebook servers where you actually deploy some instance and it's running a Jupyter notebook and people log into that and use that instead. That also has the benefit of having all the notebooks exist in one place. And so you're kind of using a notebook server to work with your data. It's also in the VPC, which also has benefits. There's other approaches like Google Colab is obviously a very popular one, where you use a web-based tool. The thing of notebooks is notebooks, they are, and oftentimes with MLOps, with people who use and deploy like real production models, um, you're usually using the notebook to interact with your production systems too. So it's not just where you do experimentation. Obviously, that's a big piece of it, but it's oftentimes where you'll actually interact with your feature store, where you'll interact with your experiment server, you'll interact with your deployment, and more. Jupyter isn't the only style of notebook. There are other notebooks, like Hex and DeepNote are two examples specifically. These different notebooks, it's they're almost like different IDs. They have different benefits. They're maybe shinier in some ways. They are able to do things automatically. They maybe have better graphics in some way. It's worth looking at, I think. Um, but I think the questions generally fall into one, what kind of notebook are we using? Am I fine letting people just work locally with notebooks and have local notebooks? Are we putting those into Git and just having people run locally? Are we using some notebook server, which solves a lot of network issues? Are we using Colab, where it's kind of almost like a serverless form of a notebook server? And are we even using Jupyter? Because I think that's another question. So I think that's where I would start. That touches all the parts of the life cycle. It's almost like the hammer of like the toolkit of data scientists. It's just like you need to have some place to work for your notebooks. Now, everything else is kind of where it gets more interesting and more complicated. So on the right here, I showed that there are those four stages of the ML life cycle, from the data to the monitoring evaluation. On the left, I'm going to show you these four layers of, or five rather, layers of abstraction from the hardware up to the platform. We're going to go through all these pieces. You can actually put them, like attach them like this and build a grid. And with that grid, we will be able to talk about, this is my dissection of an MLOps platform. So we'll go through all of these pieces. The only thing that's not really included here is the notebook management, which I touched on, but that kind of touches all of this. So let's begin at the lowest layer, which is the compute framework and hardware. This is kind of the first question to answer if you're building, again, an MLOps platform from scratch. There's really, I would say, two options here on the hardware side. One, which is by far the most common, is to go with some cloud provider. That could be the AWS, GCP, Azure. The other option, which has definitely gained more steam as of recent, is to go one of the serverless providers. Vercel has kind of become a big player in this space. Modal, Banana.dev are other two. They provide pretty much, rather than working directly with hardware, like, oh, I'm deploying even a VM, like I'm deploying a VM on EC2 or on AWS, you can just deploy functions. And then Vercel, Modal, Banana, they just run those functions for you. It kind of abstracts away So like the serverless ones kind of combine layer 0 and 1 into one layer that's really based on just functions. It also makes things like deployment much cleaner. It's much more rare, so I'm going to focus much more on the cloud providers because that is a much more common pattern. With the cloud providers, if you have the option, usually you don't, but if for some reason you have the option between AWS, GCP, and Azure, I actually don't really have a strong preference. I've at this point had to use all of them. I'm probably the most partial to AWS just because I've used it the most. But really, I think what matters here is what managed services do you like to use? Like if you love BigQuery, then use GCP. If you really like using DynamoDB, then use AWS. If your whole team is familiar with AWS, then probably just use AWS. The next piece is a compute framework. Um, and really the question is to Kubernetes or not. Pretty much every MLOps, like every tool, more or less in MLOps, especially the open source ones for deployment, for especially deployment, like model deployment, and feature stores, like the data piece, almost all of them are tied to Kubernetes on the MLOps side. The thing with Kubernetes, obviously, is it adds complexity. And I actually think that what makes things a little bit easier is some of the cloud platforms actually allow you to deploy a managed Kubernetes. So going here, typically you don't even really get a choice, but I said I would start from scratch. So if I was starting from scratch, I would probably do something like AWS and I would deploy Kubernetes via EKS. Um, Kubernetes is really painful, but it has kind of become a standard. And assuming you're working at some level of scale, if you have a single data scientist, then don't deploy Kubernetes. But I'm assuming you have at least a team of data scientists. Kubernetes just unlocks a lot of things. Even if you don't use it directly, and your data scientist almost surely should not be using it directly. But if you're running an MLOps platform, having Kubernetes allows it, makes it much easier to deploy other MLOps tools. Now, above the hardware and compute framework layer is layer 2 and 3. This is going to be the meat of the presentation because I think this is what makes up MLOps. These are the different components of MLOps, from the data all the way to monitoring and evaluation. Now you'll notice that I've kind of broken up the MLOps layer because, and so like to be clear, like layer 0 and 1, like Kubernetes is not an MLOps tool, right? Like AWS is not MLOps specific, but we build on top of these things. So it is important to be aware of them and to know either what you already have here or to choose the right one for you. This is extremely specific to ML, from the data side to experimentation to deployment and monitoring. Each of them have different tools. I will name a lot of those tools. And the other thing which maybe you've noticed is that there's two layers here. So I break MLOps into two layers. The two layers are what I would call the engine and the workflow. The engine is typically like it sits above the compute. It's typically where the compute happens. So things like training, things like running a transformation or storing a feature. That lives, in my opinion, on the engine layer. Even serving, like the actual serving container is the engine. Now, the workflow layer is much more about orchestration. It orchestrates the engine. So, for example, I might be using Spark as my engine, but I might be using feature form to define my features and define my training sets, and feature form will orchestrate the engine. For serving, you might be using something like Seldon. And the Seldon, there's Seldon Core, which is actually the server that actually runs the model. Above it, there's the rest of the Seldon framework, which makes it easy to A/B test things. It allows you to do multi-arm bandit deployments. I'll get into all that stuff. But the idea is that for every single thing, from data, experimentation, training, deployment, There's the engine piece, which is actually running the compute, doing the heavy lifting. And then there's the orchestration and workflow piece. I would say a lot of the value comes from the orchestration and workflow piece, but you have to be clear about what you're using as the engine. So let's start with the data. So data scientists are obviously like where they start is with the data. You need the ability to transform that data. Now, if you're working with really small data sets, that could be just pandas, it could be DuckDB. If I was working at kind of a pretty ad hoc, smaller team, smaller data, that's what I'd probably go with, something very simple, or even just a SQL database, if SQL is performant enough. Now, assuming you're working with larger data, you probably need something like Spark. You can use Databricks to deploy it. And if you're, so that's another piece is like, is my data, how am I transforming and analyzing my data? Which is really a question of data size and also a question of what are your data scientists most comfortable with. So I would really understand that piece first, and that would set up the core of my data. That's where my data is stored, where it's transformed. It could be Spark. You might need a low latency store like Redis to serve features for production. Um, Now above that, right? Like unless you want your data scientists themselves writing PySpark jobs, Spark submitting them, working in Airflow, you more often than not want some form of feature platform above this. Feature form, obviously, that's why we built it, was to solve this problem. But there are others, like there's Feature form and Feast are the two big open source ones. We will again be doing a comparison of that in 2 weeks, a webinar in 2 weeks about comparing them. But how you should think of it is, hey, what are the data services I have or am going to use? And the question there is, how big is my data? Do I need anything real time or online, or is it all batch? If it's all batch, you don't need Redis. Um, And then finally, what are my data scientists familiar with? Are they more SQL? Are they more data frames? And choose accordingly. If everyone prefers data frames, then Spark or Pandas is probably better. If everyone's more SQL heavy, then maybe you want Snowflake or DuckDB, again, depending on size of the data. So this makes up the first piece. So data scientists within a notebook. Um, Data scientists within a notebook like this, if we're using something like feature form and Spark, like what I have here, you can define these transformations. This piece is just PySpark, so this is a Spark specific. And then feature form is kind of the framework. With feature form, what you're doing is you're taking the transformation and then you're kind of declaratively defining it. So feature form will take this, it will make it searchable in a catalog so that you can see what was built, you can reuse things. It will run it on Spark for you. So it's orchestrating. It's like the metadata layer and the orchestration layer. And this pattern you'll see over and over again in MLOps. There's the engine, in this case Spark, and then there's the orchestrator, which kind of makes the engine work for the MLOps use case. The main questions to answer for the data stage, for the engine, is how big is the data? Do we have streaming data, which is obviously going to come with its own set of tools? What's our latency requirements? Is this a batch problem? Batch scoring is completely different. If it's real time, then yeah, we're gonna have to think about serving features under a certain level of latency. Then there's the workflow problems, which is how are we going to do versioning on features? How do data scientists analyze their features? How do we get features out of a notebook in a production? What are we defining that in? How are we going to monitor features in production? Feature values change over time. They almost always will. How can you catch that before it causes errors? Lineage. So you look at a training set, you can understand what it is. Sharing, reuse, collaboration is going to be really important, especially if you're beyond just a handful of data scientists. And then finally, governance. Governance is going to be either extremely important if you work at like a major financial institution or health institution, Or it could just not matter if you're just like a marketing startup or something. So these are the two parts of the data stage. And that's, again, the leftmost column here. Now, obviously, this is machine learning. We're going to be working with models. When we work with models, I need to be able to train that model, which means I need compute. There are services to do this. Like again, like SageMaker has its own training service, where you can configure a training job and send it there. Kubeflow has training services. There's like Determined AI and some other kind of specific companies that do training services. Above that, there's the orchestration and management, and those are experiment trackers. So MLflow is the example I'll give here. With MLflow, you will be able to, if you deploy MLflow, again, I have an example. Um, if you deploy MLflow, when you're training, so like this code right here that I'm highlighting, this is the very specific um, training piece. Like this has nothing to do with MLflow. Now, this fit rf.fit is obviously training the model. That's a pretty can depending on size of data, that can be an extremely heavy operation. In this case, it's just running locally. If you're in Colab or run on Colab, um, if you set up some sort of training service, an engine for training, you can actually send these parameters to the training service and it will be trained there. And typically that will be distributed, it will have GPUs, it will be much heavier. If you don't need that, then don't do it. If you do need it, then it's almost surely going to be required to allow you to iterate fast enough. Now that's great. I can use that to train models. That's going to create a ton of different models as I train different ones, try different hyperparameters. But then the next question becomes, well, how do I keep track of those? How can I track what those models were, what there actually was? Sometimes they maybe didn't converge, right? The train failed. Why did it fail? What happened? What were the different metrics and how did they look over time? So those sorts of questions are the questions that things like experiment trackers like MLflow solve. So something like MLflow, you're going to get a solution to a lot of those problems. You'll be able to log your parameters, log your inputs, log your metrics, log your models, and all of those become searchable and usable. So you can look at any experiment, any model, understand what it was and how it was defined. This kind of goes into the next piece of the model stage, where there's the engine problem, which is distributed training, and then the workflow problem, which is experiment tracking, model artifact tracking, comparing, contrasting different experiment runs, different models, debugging, just like why did my model not converge? How did it behave? So that becomes the model stage. Once a model is defined, we need to deploy it. Again, there's the engine and there's orchestrator. Over and over again, same pattern. And it's interesting because it's not like we all came together and decided this was the best pattern. It's just every one of these different verticals came up with the same pattern. There's the engine and then the orchestrator. I'll give an example here of Selden. So I'm actually going to go straight to their GitHub because I think they have a really good image that I like. If I can find it. Maybe it was. The thing that Selden provides is two pieces. One piece is just the actual server that runs the model, like Model A. Now that's the engine, right? Like the engine is how can I deploy my model? Now, in practice, I'm going to be iterating a lot. I might be deploying different versions of models. I might be doing things where I do a canary test. I have a model in production, but I want to deploy a new version of the model. Now, for risk mitigation, I might only run that model on 1% of users at first, just to make sure that everything's working as I expect. And then I kind of widen it to everyone. That becomes the orchestration piece. Now, you can imagine as a data scientist, it's not something that you're going to be super, super familiar with, like building and scaling and doing things like green blue deployments on of models is not something that you are probably an expert in as a data scientist. What you're really good at is building great models. And so what the MLOps platform does in this case, what these two pieces come together and do is one, allow you to actually deploy the model itself. You can package it and deploy it with its proper dependencies in a way that is highly scalable, very easily to hit. And then with Orchestrator, the piece above it, it gives you orchestration and management so that you can actually define, hey, here's what models I want to deploy, or I want to deploy this new version. I want to A/B test these two things, and all that gets solved for you. The two problems to solve here, one is scalability, uptime, and latency of the engine. Like, is this engine, the single server running your model, is it fast? And does it stay up? Is it performant enough? And then the workflow, which is A/B testing, upgrade, downgrades, canary deployments, having a clean API for inputs and outputs. So these are kind of the two things to take into account. The final stage is the evaluation and monitoring stage. Similar engine orchestration. There's a lot of the companies here. I think the most popular open source one is a company called Evidently. Evidently gives model observability. So model observability, once the model is in prediction or in production, you can look at the model and you can see and understand what it's predicting, how it's behaving, and this will allow you to be able to catch problems. If you don't deploy with monitoring or evaluation, you either don't learn about degradations until it's too late, or when you hear about the models not behaving well, you just don't know why. Like it's really hard to figure out why. And so what this allows for is two pieces. One is just the ability to actually log all the, maybe the sample of predictions that you need, analyze them, be able to make sure that it's behaving as expected. That's the engine. The other piece is much more about the UI, which is just like being able to dig into and understand why it's doing what it's doing, explaining where it's failing, alerting when something bad happens. It's really painting the picture of what the model actually does in production. So that was a lot, from the data to the model experimentation, to deployment, to monitoring, to evaluation. There is the final layer, the platform layer, which I think is really important, especially for teams building. Every team is going to have something that sort of looks like this, right? Like you have problems around data, you have problems around training, you have problems around deployment, and problems around monitoring. But the way your team works, the way you like to work, your optimization, some companies may be much more risk averse. So they're much more focused about risk reduction over anything else. Other companies maybe are just fully focused on speed. There might be there's surely other internal tools that you're associating with and attaching to, other UIs, other links. And I think this is where layer 4 comes in. Like I can give you Spark, I can give you a training engine, I can give you Kubernetes. That's the leftmost side. It's like the Lego blocks. Putting them together, this is what builds like with feature form, what we kind of do is we're a way to put together Spark and Redis to work together like a feature platform. With Selden, similarly, with MLflow, similar. They build these subsystems. There's the data subsystem, the training subsystem, the deployment subsystem, and the monitoring subsystem. But MLflow and feature form were integrated, but it's like two different UIs, two different modes, two different frameworks, so you'd have to jump between. What we see the best companies do is they provide an abstraction above all of this to give one unified experience, which is really specific to that company. Like the way Uber and Airbnb do MLOps, even if they use the exact same subsystems, is just going to look and feel different. And that's where the final piece comes in, the platform piece, which is above all of that. There's a ton of tools for all these different things. from orchestration. We have Seldon, we have Bento on training for the ML flow, weights and biases, excuse me, common side. Even on the platform layer, there's some pre-built platforms like Kubeflow, Flight, Metaflow, ZML. Um, and the feature store side, there's like Feature Form, there's Feast, there's Tecton, there's others. On the services, the engine, there's tons. Like, I mean, there's like a million, databases that kind of fit there. It's not the engine for data is not really ML specific. It's usually just like a database or data layer of some kind. And then feature form is what makes it into a feature store, a feature platform, into an actual place where you can define, manage, and deploy your features. Now, let's say I was building from scratch. I wouldn't go and build all of these things immediately right now, first thing. I would try to understand where are core pain points. If you're at a computer vision company, for example, your core pain points are likely in evaluation and monitoring, way on the right side. If I was choosing what to do and what to focus on, I would focus there. This goes back to the ROI metric, which we're actually just about to jump into. But I think it's important, and I really want to make sure that the takeaway here isn't if I'm building from scratch, build everything, get every tool, get them all working together. What I try to do here is show you all the different tools and all the different verticals and the problems that they solve and some example tools. What you pick and where is going to really depend on your company, your problem space, and your data scientist to an extent. In the end, that's what we do. We enable data scientists. Which kind of gets to my next point, which is like the point of MLOps is not to deploy every shiny new tool. So what is the point? Like, how should we think about MLOps? Well, firstly, the most important piece, like what MLOps does is it enables ML teams. Now, for MLOps to make sense, the ML team has to make sense. So ML teams have to be driving real metrics. So if you're Spotify, like you should be, like the recommender system at Spotify clearly is driving real metrics, like in this case, time spent listening. So if the ML team is able to iterate better, iterate faster, and that model is able to continue to improve, that's directly tied to revenue, which is great. That's where you want to be in. And then for MLOps, you can justify the value and the ROI, the return on investment of investing in your MLOps team and MLOps stack by showing how much better it makes ML team. A common view of MLOps metrics, which is, I think, correct and important, is very similar to DevOps, which is deployment frequency, how fast can we get models in production, how hard is it to iterate, how long does it take to iterate on the model, how often do things fail, and then when things fail, how fast can we fix it? And then there's the metrics I mentioned earlier. Velocity, like how fast is a data scientist moving? How many data scientists can work together? That's collaboration. It creates more value. So 5 data scientists has the same value as 7 because they are able to collaborate. And then risk reduction. So I just showed you 3 different types of metrics. There's like the revenue metrics. There's like 2. There's the DevOps metrics and there's the velocity metrics. Some people like ask me like, what is the North Star for MLOps? And even though I think that these things they're obviously important or like required, like you need to make these things better. When I'm thinking about building an MLOps platform, I like to think of it firstly in the thinking of a platform as a product. So when you're a product person, you start by thinking about your user. In this case, your user is a data scientist. And as you can kind of see from this, like data scientists and ML engineers typically have very different backgrounds. That means typically the way that we problem solve the way an average data scientist and an average software engineer problem solves is going to be different. And it's going to be way more like the data scientist way of thinking is way better for data science. And then the software engineer way of thinking is better for software engineering, which kind of makes sense. But I think it's important to start and think of who is our user and what are we trying to do for them. In practice, what we're trying to do for them is make them productive, make them able to accomplish their job of building and deploying better models. And part of that, and a huge piece of that, is just solving cognitive overload. Like if to deploy a feature, I have to use Airflow and I have to use Spark Submit jobs and I have to materialize into Redis and then I have to point my model that I deployed via Kubernetes and have it auto scale. Like when you start thinking of all these different things, it becomes like heavy cognitive overload, even for someone who does it for a living. But for a data scientist who's not going to be your best infrastructure person, it just does not make sense. So a lot of the goal is to solve that cognitive overload and to make it so that they can be kind of in flow. Like it's like, hey, I have this hypothesis of a new feature. I'm going to build it, try it out, test it. If it works, I'm going to A/B test in production. And then I'm going to monitor and evaluate it, make sure it's always working. The three metrics I show kind of provides how I think of the metrics of MLOps, which is kind of a pyramid. At the lowest layer, there's the basic infrastructure metrics. Can I handle the amount of data I have? Can I serve it at the latency I need it to be served? Does it stay up? Like, does it like constant? If your MLOps platform is going down all the time, it doesn't matter how, good everything is. It's just not usable. So the lowest layer is just the basics. Can you train a model? Can you build your data sets? Can you deploy that model? Can you do that all quickly? Like does it actually is it serving fast enough? Is the latency good? Is the uptime good? Is the throughput good? Once you have that, then you get to the next layer. You can focus on the next piece, which is how fast can we iterate? Now we can actually deploy something that works. Like if we deploy them all, we know it will stay up, we know it's fast enough. But now it's how can we optimize the iteration speed? So there's a lot of focus on kind of those more DevOpsy type metrics. How fast can we get models in production? How fast can we test new features? How fast can we train the model? It's really how fast can we validate hypotheses and get those in production. Once we have something reasonable there, there's the final piece. And I think this is the piece that's often forgotten, and oftentimes the most important piece for most companies, which is the product metrics, which is, let's say I build an MLOps platform and it's really fast and it really makes it possible to iterate quickly. But it's so unintuitive and so unnatural to my workflow that I just avoid it at all costs as a data scientist. Well, it doesn't matter then, right? You're really, again, thinking like a product person. Like, who's my user? How much are they using it? How deeply are they using it? And why? Once you have the basics of like, hey, if you use this thing, it will make things iterate quickly. It will give you basic like requirements around latency and throughput. Then you can be entirely focused on building the best product experience possible. So we should be thinking about things from the product perspective, the satisfaction perspective, and then just the basics, the reliability, the availability, and the scalability. And I think as you bring all these things together, you can start to really break down where your pain points are. Maybe people love to use your product, but it always goes down, your platform, but it always goes down. I mean, then you can focus on those metrics. Let's say your platform is very reliable. It works in theory, but no one's using it. Then you can kind of go into product hat mode and really focus on how do I iterate on my product experience, my platform experience. And understanding your user stories. Like a single data scientist is going to have very different problems and pain points than like a massive organization. But this all comes together to build our MLOps platform. Um, Together, you can stop thinking about tools as like, oh, there's 4,000 MLOps tools. Which one should I use? But rather, if you use this framework that I provided, you can start to think of where are my pain points. You can think of those metrics I talked about and understand and talk to your data scientists, really understand where their pain points are, break it down via this kind of breakdown and understand, okay, it seems like the most investment we should make is in our data layer. Maybe we need a feature store. And being able to back that up with ROI, being able to measure that correctly and see that it's providing value. In the end, if you're a giant enterprise, you surely have all of these pieces. Some of them are probably built in-house. But if you're starting from scratch, I think just starting with this layer, building up, and then figuring out kind of the order of operations based on your problem statements, and then backing them up with metrics from just basics like uptime and availability up to like usage is what would allow you to build the best possible MLOps platform from scratch. So that's all I have today. I had something on LLMs, but I don't think I'll have time to do it, so I'm not want to start a section and not finish it. If there are any questions on LinkedIn, Twitter, anywhere, you can throw them up. I'll answer them. We have about 10 minutes where I can answer any questions that you all may have. And then Marie, you'll let me know if there's any on LinkedIn or Twitter, please.
Will do.
Well, I'll give a minute for any questions to be written. I also want to add that Marie's going to send a follow-up email. That follow-up email will also include links to the next couple webinars if you want to learn about some of our other topics. It'll also include a link to our community, which is a great place to keep up with all things feature form, all things MLOps. It's like has hundreds of MLOps practitioners in it. It's a great place to learn. And otherwise, unless I'm missing anything else, Marie, let's give another minute for questions. And then otherwise you can call it for today.
Cool, yeah. As Simba mentioned, I'll send you guys a little follow-up email today, this afternoon, with the recording of this webinar, also links to our communities, and also if you have any feedback about our webinars and workshops, if you'd like us to talk about a certain topic, feel free to give us that feedback. We love that kind of stuff. But otherwise, yeah, I think that's everything.
Awesome. Great. Is there any last questions right now? I guess not. All right. I'll give it back to you, Marie, as host, and then you can end it for us today.
Awesome. Have a great rest of your day, everyone.
Thank you, everyone.